Welcome to The Explainer. Today, we're diving into the brilliant tech that lets your phone translate languages on the fly or powers those chatbots you talk to. We're talking about how machines really learn to understand and generate human language. So let's kick things off with a question you've probably asked yourself. You type a sentence into a translation app, and what comes out is a totally different length. How in the world do machines handle that, where the input and output don't have a simple one-to-one match? Well, the magic behind this is an incredibly clever model that was built for exactly these kinds of jobs. And the name gives it away. It's called a sequence-to-sequence model, or just Seq2Seq for short. Okay, so what exactly is a Seq2Seq model? Really, you can think of it as a team of two, each with a special job. First, you have the encoder, which is kind of like the reader. Its job is to process the input. And then you have the decoder, which acts as the writer, generating the output. They work together perfectly to turn one sequence into another. All right, let's zoom in on that first specialist, the encoder. Its entire mission, its whole purpose, is to read and actually understand the input sentence we give it.
But that brings up a really big question, right? I mean, a sentence is just a string of words. How can a machine look at that and somehow get the bigger picture, the actual meaning behind it all?
Well, it's pretty smart. It doesn't just gulp down all the words at once. The encoder actually reads the sentence one word at a time. It starts with how, then it reads are, but it remembers the context of how while it does it. This process just keeps going until it hits the very last word, building up its understanding with each step. And this is where it gets really cool. After it's read the entire sequence, the encoder squeezes everything it's learned down into one single numerical summary. A great way to think of this is as a thought vector. It's like the model's single concentrated thought that captures the entire essence of the sentence. So now what? We've got this thought vector. Let's move on to the second part of the team, the decoder, and see how it takes this thought and actually starts writing with it. So how does that even work? How can you take this one dense chunk of numbers and unfold it into a completely new, human-readable sentence? The decoder's job is basically to act like a writer who's been given a single core idea and now has to flesh it out into a full sentence. It all starts with that thought vector. The decoder uses it as a prompt to generate the very first word of the new sentence. Let's say it's comment. Then it uses both the thought vector and that first word, comment, to predict the second word, saw. It's like a chain reaction that just keeps going, word by word, until the model generates a special end-of-sentence signal telling it, okay, I'm done. So the big takeaway here is this really elegant two-step dance. The encoder, the reader, takes in a sentence of any length and boils it down to one fixed-size summary. Then the decoder, the writer, takes that one summary and generates a totally new sentence, which can also be any length it needs to be. Simple as that. Now, I know this might all sound a little bit abstract, like it's just happening in some lab somewhere. But the truth is, you're interacting with this technology all the time, probably every single day. So let's pull back the curtain for a second. Where are these powerful Seq2Seq models hiding in plain sight? Oh, they are everywhere. Machine translation is the classic example, of course. But this same architecture is what powers the chatbots you talk to, the systems that can find a specific answer in a huge document, and even the services that turn your spoken words into text. It can even be used for image captioning, taking a picture and writing a sentence about it. How cool is that? And that leaves us with a pretty mind-bending final thought. This idea of a thought vector, a bunch of numbers that represent a complex idea, is just so powerful. It really makes you wonder, if we can teach a machine to compress a whole sentence into a single thought, what are the real limits here? What can it learn to think about? Thanks so much for watching. Hey, if this helped you finally get your head around Seq2Seq models, do me a favor and hit that like button, share it, and subscribe to The Explainer. We'll keep making these complex topics simple. See you in the next one.